talking about conduction. It's our big term, conduction. And conduction is one of three ways to for heat transfer. So it's a method of heat transfer. So a method of heat transfer. And this particular method is when we transfer heat through direct contact. So you have two different materials. Say one of them is colder, one of them is warmer, or is a higher temperature, higher temp, and then you get heat, which is Q. Heat flows from the higher temperature material into the lower temperature material. So remember, we always have heat flowing from high temperature to low temperature. That's why last week on the question, if you touch something and it feels cold, is the cold flowing into you? No, actually things feel cold because heat is leaving your body. So heat is going from your higher temperature body into the lower temperature other substance. So conduction, method of heat transfer, through direct contact, which brings up a couple other key issues. That we have things which are conductors and insulators. Conductors move heat well, and insulators move heat poorly. Move heat poorly. And while technically thermal conduction and thermal insulation is different than electrical conduction and insulation, they do kind of work through similar processes, and usually good conductors of heat will also be good conductors of electricity. So good conductors are most metals, in particular silver, copper, gold. Those are all pretty good conductors. So in general, you're looking at metals. For insulators, air is a good insulator. Water, foam, usually is a good insulator. Wood. And the way you want to think about that is, if you've got a piece of copper here, and you light a fire on one end, the whole bar is going to be hot. You don't want to touch the other end. That's going to happen fairly quickly, as opposed to something that's better insulator. So you have a piece of wood, and where we live, we've been at bonfires. We've seen people do it. You can have your fire on one end. Of course, what happens is then the wood catches on fire. But if you've got a nice log, you can still hold on to the other end. That's because the heat isn't flowing through the wood like it would flow through copper or most metals. Now, conduction certainly is really, really important, and we'll see that when we go over to here, bring it down, because I need to eat. Eating is important. So I have a griddle here. It's just a hot plate, and it's got electricity running through it on the bottom, which is causing it to heat up. So I'm actually going to use conduction to cook part of my lunch today, making sure I'm in frame there. I am. So butter has a pretty low specific heat, which means it's going to absorb heat very quickly. This is why you can see I'm melting real fast here. It's a good thing. Mistake you want to keep in mind is don't leave your plastic spatula on your 100-degree griddle, because it will melt. So I'm going to apply heat from my griddle onto my egg here. And that is direct thermal contact, which between the griddle and the butter. Butter is then letting that heat go through pretty quickly. So that's onto the egg. Let that guy go. Lowering my heat just a little bit. And so anytime you're using like a saute pan or a fry pan, you're cooking something on the stove and it's not like immersed in water, or so it's just like on the fry pan or on the griddle here, you're using conduction to cook with, and that's a really important issue. We're going to see some other examples of different cooking method, which are going to use the other two main ways of heat transfer, which are going to be convection and radiation. Today, talking about conduction, and we are just frying an egg on the griddle. So conduction, heat transfer through direct contact. Egg is touching the griddle is hot, thus the egg is being cooked. And that is all for today. So your assignment is going to be to post in the discussion board what is conduction in your own words, and what was I cooking? The answer is going to be Friday.